Hello everyone, I'm Xingfen Shao from University of Southern California. Today I will present our work about layer-dependent perfusion imaging using ASL and 7 Tesla. And I have nothing to disclose. 70 ASL has several advantages. First, SNR increases superlinearly with field strength, and also arterial blood T1 is longer than 7 Tesla. There are also challenges in 70, including B1 and B0 field inhomogeneity, and also shorter T2 of arterial blood. So here's a B1 map we acquired N70 using single transmission coil and dielectric paths. As you can see, B1 is very inhomogeneous. And this typical 3D Picasso labeling plane here, B1 is usually less than 50%, leading to a very bad labeling efficiency. So here's our approach to deal with these challenges. First, we utilize a zoomed acquisition covering the smaller volume around primary motor cortex. So here in the red column, you can see the 3D view of ASL control images and its relative position in the whole brain. So secondly, we utilize a new labeling strategy by moving the labeling plane above the circle villus here and perpendicular to the MCA. So this labeling position has higher B1 and a more homogeneous B0 field. Arterial transit time from labeling plane would also be shorter, and flow velocity is slower. So as a result, we can achieve higher labeling efficiency within a shorter TR and without exceeding the SAR limit. So high spatial resolution ASL images were acquired with 1 mm isotropic voxel size on 7 Tesla using a single transmission coil. We have scanned 6 healthy subjects, and each scan duration is about 70 minutes. 20 cortical layers of M1 were segmented using Laney. So each scan has 4 rounds of task ASL and PLD of 1 second. Each round is about 10 minutes and has interleaved the 9 blocks of the resting state ASL, finger tipping or finger brushing activate ASL, and the order of those tasks were counterbalanced. Additionally, we have 2 more resting state ASL runs and 2 PLDs about 500 and 1500 milliseconds to review the dynamics of the ASL signal. So here are the perfusion maps acquired and 3 PLDs. And our early PLD of 500 milliseconds, perfusion signal mainly remains in pure surfaces, and a longer PLD of 1 and 1.5 seconds, majority of the ASL signal reached into gray matter. Here's the resting state CBF map estimate from 3 PLDs. And here shows the laminar profile of perfusion signal and the 3 post-limit delays across cortical layers from white matter towards CSF. The perfusion signal increased towards CSF boundary and PLD of 500 milliseconds, and the peak shifts towards middle layers and longer PLDs. In this plot of the laminar profile of arterial transit time, we can see the labeled blood first arrives in near pure surface, and about 100 milliseconds later, it arrives in middle and deep layers. In this bottom plot, CBF profile shows a single peak in the middle layers. If we look at this photo of vasculature network of central sulcus, the left and right side are sensory and motor cortex respectively. The darker area indicates higher vascular density, so based on the inverted intensity within this red box, the relative vascular density profile can be obtained as shown in this plot. It matches very well with our CBF profile, which peaks in the middle layer and slightly towards CSF boundary. So here are the CBF maps and the resting state, and during finger tipping or finger brushing tasks. These 2 enlarged windows show CBF increase invoked by finger tipping on top, which shows strong response in deep and superficial layers, and finger brushing induced CBF increase mainly in superficial layers. So here are the laminar profile of CBF at resting state and during finger brushing and finger tipping. And here are 2 plots shows the absolute and relative CBF increase in response to finger tipping, the blue curve, and finger brushing, the orange curve. So CBF response to finger tipping shows a clear 2-peak pattern in deep and superficial layers, while finger brushing shows a weak response in superficial layers. And compared to both signal response, which is on the order of 1 to 2%, relative CBF increase is around 50% to 150% invoked by activation. So these 2 dashed lines here shows the relative CBF response after correcting for both signal change. Our CBF response is highly consistent with theoretical neural circuits response. For finger tipping, CBF increase in superficial layers corresponds to sensory input from S1 and premotor cortex, and CBF response in deep layers is related to spinal output. While for finger brushing, a weaker CBF response in the superficial layers is related to sensory input from S1. In conclusion, laminar perfusion can be measured by ASL and 7 Tesla. Resting state data reviews the dynamics of the labeled signal, and the CBF profile is highly consistent with the neurovascular structure. ASL perfusion also offers a quantitative measurements as compared to bolt or Rizzo fMRI. We also demonstrated high spatial specificity and sensitivity of laminar perfusion fMRI. For more details, please refer to our new paper on bioRxiv. Thanks for your attention.